Inside which there is an object, you are looking from above. This is I1, and he observes some apparent depth. You are also looking from below. Yes? And he observes some apparent depth. Then they are asking, what is the thickness of the slab? What is T? This is the question. Try to do it. Let me give you 3 minutes and then I will start. So at 10:15 I will start. It's a fairly simple question, it's just one line. I'm still giving you time. Is it okay with everyone? Is it straining your eyes or anything? No? Option D. Yes, that's correct. Option D is correct. Anybody else? Option D. Good. Should I start with it? Option D. Good. Yes. Okay then, I'm starting with the question. I think the apparent depths as seen by the observer is given, na? Yes? But what are the actual depths? What will be the actual depth as seen? Maybe that will be D1. Huh? That is D1, the actual depth. And what about from this observer E2? That will be some D2. Then what will be the thickness T?
D1
Just D1 plus D2. So I need to find the actual depths. And can you tell me, by the way, which case is this?
Second case.
Is it second case or first case?
First case.
In the case number 1, this is what I have been talking about. It's the things that I was asking in previous lecture and nobody was telling. Which case? It's a real object first of all, so it has to be case 1 or 2. Where is the real object placed? Inside denser medium or in air?
Denser medium.
So case 1 or 2?
Case 1.
Case 1. Do we divide by mu or do we multiply by mu? Divide by mu. So D apparent, ये सब याद रहना चाहिए. D apparent 1 as observed by E1 is D1 by mu. Then what should be D1? Mu times D apparent, right? And what is D apparent given to be? 6 centimeter. What is mu given to be?
1.1.
So ये multiply करके बताओ. 6 into 1.5 9 centimeter. Will the same occur for the observer 2? And it should be D2. That's mu times D apparent 2, and that will be 1.5 into what? 8. 8 times 1.5 is what? 12. And if I add the 2, will I get the thickness?
Yes.
And I think 9 plus 20, 12, 21 centimeters. This was fairly simple. If you are done with question number 2, go for question number 3. Go for question number 3. Is it visible to you people when I teach? People in the back? Okay. Go for question number 3. And please write names at the top of your sheet so that it doesn't get displaced. Option A for question number 3, that's correct. Again, a very simple question. Yes, A. Even simpler than question number 2. If you're done with 3, go for 5. Rather, go for 6. 6 is easier. Anybody else with question number 3? AI? Good. Go for 6. Okay then, I'm starting with question number 3. In the question number 3, what is mentioned? I think it's given that you have a bird at some height from the water surface, and inside the water surface there is a person at some depth, and the person is trying to look into the the bird, and where will the bird look? Where will the bird feel like it is? That is what they are asking, the apparent height. So, what was the formula of apparent height then? Do you remember? Now tell me which case. You have a bird. Second case. Bird is a real object or a virtual object?
Real object.
Real object. A real object in air. So it's case number 2?
Yes.
Good. So for case number 2, do we divide by mu or multiply by mu? Multiply by mu. So H apparent, let me say, H apparent will be mu times H. What is the actual height of the bird?
18 from the water.
18. What is the mu given to be?
4 by 3.
4 by 3 into 18. That's what? 24. You are done. That information about the person is at some depth, that doesn't matter to us. 6 wala? B, that is 31. Correct. Good. If you are done with 6, go for 5. Did you understand the question? Just multiply, nothing else. Question number 6. Let me wait 2 minutes and then I will start. Question number 6. I think 6 is fairly simple again. It's a single formula question. 31 आया? Single formula question. Should I start with 6? For those who were present, I think this is fairly simple to understand. I gave you one of the notes. Do you remember that? When you have 3 immiscible liquids. For 3 immiscible liquids, if there is a coin placed at the bottom, then what was the apparent depth? d1 by mu1, d2 by mu2, d3 by mu3. You just add all of them. Then now in the question it is given 2 immiscible liquids, even simpler. If you have 2 immiscible liquids, and I think the height of each column is given to be same, na? What is the height of each column? 6 centimeters. And what is the refractive index given to be? 8 by 5 or 8 ka? 3 by 2. You place a coin at the bottom of it, then what is the apparent depth? Fairly simple. D apparent is d1 by mu1 plus 6 by 8 by 5 plus 6 by 3 by 2. I think it will cancel हो जाएगा. 2 3s are 2 4s are, 3 1s are 3 2s are. And this is something like 15 by 4 plus 4. 4 times 4, 16. 16 plus 15, 31 by 4 centimeters. Then what is alpha?
31.
Alpha by 4 is 31 by 4. So that means alpha is equal to 31. Do you get it? Simple, no? Go for question number 5. Again, a very simple question, but a little twist. Question number 5. I will give you 3 minutes and then I will start. 10:27. That's why you should be present in all lectures. Not be absent. Now you're not getting anything. You'll see from here. You absent in one of the other lectures. You were absent as well, huh? What was the reason? Earth was shattering? Achha. Just by completing notes doesn't mean you. Did you understand everything?
I understood the starting. I didn't understand this.
You understood that?
No, I didn't understood this. I understood the starting of the questions.
ठीक है. Anybody done with question number 5? Option D. Option D. What is the question? Option D is incorrect. Very good. Option C. Yes, I think that's correct. Option C is correct. Did you get it? तुक्का मार रही बस. ठीक है. Option C is correct. Question number 5. Okay then, I'm starting with the question. I think it's given that you have a beaker inside which there is a liquid. Okay, you have a beaker inside which there is a liquid. Now you poke a hole. You poke a hole so that the mass is flowing out. When that is flowing out, the height of the thing will decrease. Yes, the height will decrease. The volume of the liquid will also decrease. They are asking the amount of water drained out, per minute. ऐसा कुछ तो पूछा है, I think. It's also amount of water. When they ask, then you may think that it's the mass upon time, but then in the units they have given centimeter cube upon minute. So this volume upon time. You have to find volume upon time, and what things are given to us. Yes, diameter is given of the cylindrical water tank, and the apparent depth is decreasing at a rate of x centimeter per minute. So they have given that the apparent depth dh apparent upon dt is decreasing, so minus x centimeter per minute. This is given, na? What is the volume of the cylinder, by the way?
Pi r square h.
Pi r square h. What is the radius of the cylinder given to be?
R.
So volume of cylinder is pi r square h. They are asking dV by dt, na? In the question. Yes or no? Instantaneous means so ये dV by dt. So I have to differentiate this. But what is the radius? Will the radius shrink? Is it?
No.
No, na? Only the height of the column will decrease. So the only thing that will change is h. So pi r square is a constant. It comes out dh by dt. But what is this h? This is actual height of the column. This is apparent height of the column. Is there a relation between actual height and apparent height now? Now tell me which case. What is this water? See, the thing that we are observing is water, na? Water is what we are observing. Water is a real object or a virtual object? It's a real object, right? Real object को हम लोग observe कर रहे हैं. Yes or no? So case number 1. Then what was the relation between apparent height and this? I should divide by mu, right? So h apparent is h by mu. Yes or no? Then what will be h? H will be mu times h apparent. Achha, by the way, not d by mu. In generality, I think I gave you mu 2 by mu 1, something like that. What it should be? Mu 2 by mu 1 है या mu 1 by mu 2? Mu 2 by mu 1. Is everybody okay with that? Then what should be h? It should be mu 1 by mu 2 into h apparent. And if I differentiate dh by dt, then mu 1 by mu 2 is a constant, comes out. This is dh apparent by dt. But dh apparent by dt is minus x, na? Yes or no? I can substitute that and then I will get dh by dt. Then what is dh by dt equal to? Pi r square minus x mu 1 by mu 2. I think in the question they have written in terms of n1 by n2, na? चलेगा और तुम लोग कर लोगे? Then what is this equal to? Minus pi r square x mu 1 by mu. Why did I write a negative sign here?
Decreasing.
Because the volume is decreasing with time. Does it make sense to you? Whatever we did? Information was given for apparent height ka rate of change, and you had to relate with actual height ka rate of change. Yes, that was the interesting part of the question. Other than that, it's a fairly simple question.
Option A.
Option C na?
A.
Acha, option A. Correct, sir. It's option A. Anyways, did you understand question number 5? Up until now, all the questions were fairly easy, but this question number 4, this is very interesting. Attempt this. This is a good question. Attempt question number 4 if you are done with this. Let me give you 4 minutes to think, and then I will start. Let me give the diagram of question number 4. So it's something like, no, actually no need. Even without diagram you can do it.
Second question.
Be very careful in this question, because some information is given that the bottom of the swimming pool is actually a perfectly reflecting surface. Huh? That will be crucial to us in this question. Should I give you a hint of how to approach the question? First, imagine that the first refraction will occur from the upper surface. That will create an image. That image will act like an object for the bottom surface that will reflect now. That will create another image. That image will be considered as the object for the upper surface again. So it's like refraction, reflection, refraction. 2 times refraction is occurring, 1 time reflection is occurring. So many in between images are considered as objects. Take into consideration all of that and then give me an answer. Should I start with the question? I will wait 1 more minute and then I will start. Option A, that's incorrect. Okay then, I'm starting with question number 4. This is very interesting, so listen very carefully. Let me read out the question. A bird is flying over swimming pool at a height of 2 meters from the water surface. Yes? If the bottom is a perfectly plain reflecting surface and the depth of the pool is 1 meter, then the distance of final image of bird from the bird itself. So I think the scenario is something like you have a swimming pool of some depth. What is the depth given to me? 1 meter. There is a bird here at a height of 2 feet. What did I tell you? How? What do we have to consider? A refraction, a reflection, another refraction. So let's first consider a refraction. Which case? Case number 1. Is your object placed inside the denser medium or in the rarer medium? So case 1 or 2? This is case 2. Case 2 mein batao, where should the image be formed? Should it be formed here, here or here? Yes, because it's formed at the same side. That is the defining characteristic. V and U has the same sign convention. So either kabhi sahi banega na? This will be image 1. What will be the distance of image 1? Can somebody tell me? If this is D and if this is height, then what will be H apparent? Should I multiply by mu or divide by mu? Very good. H apparent will be mu times H. And what is mu given to me?
4 by 3.
4 by 3 into H. What is H? 2. So this is 8 by 3 meters. This is the first virtual image formed by first refraction. That first virtual image will act like a virtual object for what?
Mirror.
For the mirror, for the reflecting surface. Then do you remember how to find the image distance? V equal to minus U. That's very simple. So what is this distance from this surface? It is 8 by 3 plus 1? Yes, that's 11 by 3. Let me also give the name of each surface, A, B, C, D. The CD is the reflecting surface. So here you will find somewhere I2. And what will be the... Acha, should I take I2 ka distance from AB or from CD? Where is my mirror? CD. So I should take from CD, na? Yes. And what is this distance?
11 by 3.
11 by, so it's like 8 by 3 plus 1. 11 by 3 meters. This is my second virtual image now. How will this second virtual image act like?
Object.
A second virtual object. For what surface now? For the AB surface. So let me write all of these things. For surface AB, first refraction. then for surface CD first reflection, and what did we find? So V2, that is the image distance for image 2, so that will be 8 by 3 plus 1, that is 11 by 3. This will act like a virtual object for this AB surface now. Now tell me which case. It's a virtual object. So which cases? Either 3 or 4. Now tell me which case. 3 or 4. Is my virtual object 4? Think carefully and then give me an answer. Let me ask you this. Does it matter where my object is placed or where my rays are hitting? Where my rays are hitting. My rays, this virtual object will have rays which will come like this and hit on this surface. So from what medium to what medium they are going? From denser to rarer. So you can assume, as good as assume, that the virtual object is placed inside the denser medium. Yes? So which case? Case number 3. कौन से case number 3 में ही हो रहा है ना ये? Yes. So should you multiply by mu or divide by mu? Divide by mu. So for surface AB, do you understand what is happening? There are many things happening in this question. Second refraction. Second refraction में, what is the final image then? V3. Where should the image be formed, by the way?
Same side.
Above, here or here?
Below. Above.
Below? Here?
No, above.
Or here? Or here?
Not above A2. Above A2.
Above I1?
Above I2. Above A2.
When image is formed due to refraction, the object distance and image distance has the same sign convention. So where should the image be formed?
Below I2.
Should be formed below somewhere here. Do you understand? Good. So V3 is what now? Can you tell me? It's V2 by mu. Yes? This is what you told me, na? Multiply करना है या divide करना है?
Divide.
अरे बेटे लोग तुम लोग केस देखो अच्छे से. केसेस जाके देखो. ये जो ऑब्जेक्ट है, ये वर्चुअल ऑब्जेक्ट, this can be considered as put in the denser medium because the rays are in the denser medium. They are going to hit like this. When you तो divide करना है ना? Divide करना है ना? पागल लड़की को समझाओ कुछ. देखते हैं. अभी देखते हैं, अगर आंसर गलत है तो मल्टीप्लाई करते हैं. ठीक है? 11 by 3 divided by 4 by 3 ना? 4 by 3 है? Correct, right? So this is 11 by 4 meter. You divide by mu, you get 11 by 4 meter. Now can you tell me from what surface is that 11 by 4 meter?
upper AB surface.
AB से, क्योंकि AB पे रिफ्रैक्ट हो रहा है ना? With respect to AB रिफ्रैक्ट हो रहा है, तो कहाँ से बना? यहाँ से कहीं बना 11 by 4.
Plus 2.
और ये कहीं I3 यहाँ पर कहीं बना. Do you understand? This is my final image. This is my final image. So many images, but did you understand what is happening here? Now what is the distance between the bird and the final image? Distance between bird and final image. It should be something like 11 by 4 plus 2, क्या? 11 by 4 plus 2.
Sir, option
ऑप्शन नहीं है.
शायद ये मल्टीप्लाई था, डिवाइड नहीं.
ये शायद क्या बोल रहे हो तुम लोग? मैं केसेस देख के नहीं बोला क्या मुझे? मुझे केसेस को देखो. मल्टीप्लाई करना है। So it should be 11 by 3 should be multiplied. So ये 4 by 3 से multiply करना है क्या? 44 by 9 ये तो गलत हो रहा है। This is now yes, I'm making some mistakes somewhere. 8 by 3 is correct. 11 by 2. Let me look into my. Arey, I did not take it.
They're only asking the final image.
No. Wait. For the second refraction, what is the for second refraction? What is the object distance? It's 11 by 3 plus 1. I did not add that. So 11 by 3 plus 1 होना चाहिए. So for second refraction, object distance. Do you understand? With respect to this surface, what is the distance of I2? 11 by 3 plus 1, na? So it should be 11 by 3 plus 1, and that is supposed to be 14 by 3 meters. And now बताओ अब क्या करना है? Divide या फिर I think you have to divide. Divide करना है ना? Divide करना है तो फिर बताओ divide करके क्या आएगा आंसर? तो V3 is going to be 14 by 3 divided by 4 by 3, and this is supposed to be 7 by 2 meter, I think. Is this correct? 7 by 2, and then let me add it, and then what will you get? 7 by 2 plus 2, this is 11 by 2. Option A. Do you understand why you have to divide by means? स्टार्टिंग से फिर से बताना है। बता रहा हूँ एक करके सब। फर्स्ट इट्स आस्क्ड यू हैव अ रियल ऑब्जेक्ट, एक रिफ्रैक्शन, एक रिफ्लेक्शन, एक रिफ्रैक्शन आएगा। एवरीबॉडी गेट्स इट? फर्स्ट रिफ्रैक्शन विल फॉर्म एन इमेज that will act like an object for this, creates another image that will act like an object for this. Does that make sense? So first I will have to find those in between steps as well, है ना? With respect to this, where is my image formed? At the same side. And how to find that? Oh, multiply and divide. Do you understand when to multiply, when to divide? Cases को consider करो. Your object is a real object, so it's either case 1 or 2. Now it's placed in air, so it's case 2. So you multiply, right? You multiply by mu and you get that answer. This is my first virtual image. That first virtual image will act like an object for this reflecting surface. And what is the object distance then? This thing plus 1. Yes or no? That will create an image here. Now this image will act like another object for this surface now. But what is the object distance then with respect to this surface? This length plus this length. That is why I wrote 11 by 3 plus 1. Now what kind of case? Now you have another refraction, but this is due to a virtual object. Virtual object यानी case 3 or 4. Case 3 or 4. Now case 3 या case 4. How to get that? Your rays, look at the rays. The rays are going from denser to rarer. Don't look at the object where it is placed. Where is the rays going? The rays are going from denser to rarer. Then in which case the rays are going from case 4. तो उसमें divide by me or multiply by me? Divide by me. समझा? So you get that as the object distance, and now they are asking to find the distance between that and that. Do you get it? This was a good question. Many things occurring in between. And उधर कहीं पर भी गलत कर दिया, then you are done. Some people may come up till here 11 by 3 and they will say that this is the final. That's why I give one of that option. Good. If you're done with this, then tell me. So we are done with the topic of refraction, single refraction from the surface.
Considering the placement of the object, but we are considering the rays.
What do you mean?
We are considering the rays for the virtual object.
Rays matter.
But the real object we are considering that the object is rays.
Because the real object is placed in the same medium as the ये इधर real object इधर आके hit किया इसकी rays आई. From where are the rays? Rarer. Where is the object? Rarer. So rays and object are both in the same rarer. ठीक है? Good. If you are done with this, then tell me. I will start with a new topic. Shift due to glass slab. Did you get it? You have to retry it again by yourself, and only then will you get it. Can I go forward? Okay, I will wait one more minute and then I will go. How many of you are writing? This is negligible number. Very easy. I think all the previous questions were fairly easy. Only this was a little troublesome. Can I start? Great. Shift due to a glass slab. So it's something like this. Let's say you have a glass slab. You understand the meaning of glass slab? Of refractive index mu. Slab of glass बोली क्या? वाह. This is where my object is placed. Let's say this is where my object is placed. Object O. What will happen? Rays will come like this. Since it's air, so everything is denser with respect to air, so it will refract away towards the normal. Then what will happen? Away from normal. Comes in with an angle I. What will it come out with an angle?
Angle I.
Angle I. It will be the same angle I. Yes? You can check it by Snell's law. Good. If I trace these rays back, then what will I get? Let's say I trace this ray back. This will act like a virtual image for the first surface. What about the second surface? It will act like a virtual object for the second surface. And then, if I retrace them back, then this will create a real image. Real image somewhere here. I1 will act like a virtual object for this surface. Let me give some names. A, B, C.
Real image is
Virtual object. Virtual object is real image.
हाँ, image ऐसे real नहीं है. Yes, it will be real. It will be an image, let's say I, image I. But do you get it that this will act like a virtual object and create this image I? Good. When we are asking the shift, then what do we mean by shift? We are asking this OI distance. How much is the image shifted from the object? So this shift will be equal to OI.
Sir, virtual object gives real image.
Virtual object gives real image. मुझे भी वही लग रहा है.
तो real image ही होगा.
ठीक है, डिस्कस करते हैं इसको, बाद में डिस्कस करते हैं. अभी लेट मी गो थ्रू द डेरिवेशन एंड देन एंड में इसको डिस्कस करेंगे. ये शिफ्ट निकालना है, ठीक है. लेट मी गिव सम मोर नेम्स. लेट्स से डी एस सी, नहीं सी डी हो चुका है ना, ई एफ. नाउ लेट्स स्टार्ट. ठीक है, लेट्स से कि with respect to this AB, E will be the pole, and with respect to this pole, this length is given to be x, let's say. Okay? The object distance from the first refracting surface is given to be x. So OE is equal to x. Or I should write EO, na? To be more precise, EO should be x. It's a plus minus, I'm not writing that right now. That will create an image. Ab batao, which case now? Refraction is occurring.
Second case.
Second case, because this is a real object and the object is placed in air. So it's a second case. Multiply by mu or divide by mu?
Multiply by mu.
Multiply by mu. So this should be this distance, EI1, and that will be mu times x. Yes or no? Then from this distance, if I consider the FEI1, let's say the thickness of the slab is given to be T, then what will be FI1? That will be mu x plus T? Yes? Do you have any problems here? Second refraction occurs. In the second refraction, what is the object? This is the object distance. In the second refraction, what is the case this time? What will this act like? Virtual object. So which cases you have to consider? Third or fourth?
Third case.
तो अब ये एयर में है या मीडियम में रखा है? एयर में. तो कौन सा केस?
Third case. Third case.
अरे तुम लोग जाके नोट्स देखो बेटे.
Third case. Fourth.
हाँ हाँ.
Third case.
यस रेज देखना चाहिए ना. बताओ सब केस बताओ.
Third case.
Should I multiply by mu or divide by mu?
Multiply by mu.
रेज देखो रेज. Don't look at the object. Divide by mu. देखो बेटी.
ऑब्जेक्ट है तो रेस इधर से जाएगा ना.
रेज ऐसे जा रहा है.
इधर से कैसे ऑब्जेक्ट
वर्चुअल ऑब्जेक्ट.
तो एक्स इधर से रेस आएगी,
हाँ.
सेंसर से रेस.
हाँ हाँ हाँ.
तो केस 4 डिवाइड बाय.
हाँ. She is very correct. That when you have a virtual object, then the rays are coming towards the object. Yes or no? Rays are coming towards the object, so it's like going from denser to rarer. So you divide by mu, na? Divide by mu. So what should be the image distance now then? तो ये Fi निकाल रहा हूँ ना मैं. Fi should be equal to Fi1 divided by mu. This will be mu x plus t by mu. What will this give me? X plus t by mu. Do you understand this? Now what is the shift OI? Can I write OI as OF minus IF? So OI, which is the shift, that is OF minus IF. But what is OF equal to? That's x plus t. And what is IF equal to? बताओ. X plus t by mu. So what do you get there? T minus t by mu, and this can be written as t 1 minus 1 by mu. This is OI. This is the shift. Now if you look into this very carefully, the shift is towards what? Towards a glass slab. towards the glass slab. Let me make another picture. This was the case for real object. The shift is always towards the glass slab. Can the shift occur in the opposite direction? That can occur for the case of virtual object. If I have a, let me make the diagram and that will be much more clearer. So let's make this diagram. You have a glass slab. Okay. The rays are coming from here. The refract comes here. The rays are coming from infinity somewhere. This will create a real image? Yes or no? Good. If I extend these rays, then this is supposed to be my virtual object, and the rays appear to come towards virtual object, right?
O dash.
So this is supposed to be O dash. Where is the shift now? Is it towards the slab or away from the slab? Away from the slab. That's very important. So when you have a virtual object, your shift will be toward away from the slab. So मैं लिख देता हूँ for real object shift is towards the slab, and for virtual object shift is away from slab. Do you get it? Write this and then let me give you some notes. First write this. Do you have any problem in the discussion? Good. Written? Those cases should be understood very thoroughly. Can I go on? after the class. Let me write some notes then. What if you have 2-3 glass slabs joined together of some thickness and some refractive indices? Then what happens? Let's say notes. And the first note is, if you have 2 glass slabs which are joined together like this, of some thickness T1, thickness T2, mu1 and mu2, then how to find the total shift? What will be the total shift? It will be the addition of the shifts. Okay? So total shift is equal to T1 into 1 minus 1 over mu1 plus T2 and minus 1 over mu2. This is the total shift. Yes? There is something called as lateral shift. So I'm not going to derive the formula, but I think the derivation is quite simple. Huh? If you want, you can go and check in DC Pandey after module 3 or 4. Right? After module 4. There is a derivation of lateral shift, but I'm just going to give you the formula directly. What is the lateral shift, by the way? Let's say you have a glass slab here. Your rays are coming like this. They bend toward the normal, then come out like this. The angles are same, na? The angles are same. That means if I were to extend this back, then this and this are basically parallel. My drawing is not so good, but these are parallel, right? Then what is the, so can you imagine this ray was moving like this and then let's say it got shifted here, basically. So what is the amount of shift that occurred? This shift. That is called the lateral shift, and that is D. Let me say that it is D. This D is the lateral shift, and D is given to be, now this is the formula. T is the thickness, mu is the refractive index. And the formula goes something like T into 1 minus cos I over under root of mu square. T equal to T into 1 minus cos I over mu square minus sin square I का root into sin I. This is the lateral shift. Looks formidable, but the ray was going like this, refracted again. Do you understand that this angle and this angle is same? Yes? So that means if I extend this ray back, this line and this line are going to be parallel. So you can imagine the ray was going like this and then it got shifted here. Then how much distance it got shifted? That is lateral shift. And I'm just going to give you the direct formula here, how that happens. And this is the formula. Looks formidable, but the derivation is quite simple. Good. If we were to consider very, very small angles, like in the case of paraxial approximation, then what will be the formula? For small angle of incidence, this will come out to be d into Ti over 1 minus, I think it's something like mu minus 1 over mu. This will reduce to that. You can even check in your mind that it will do so. You can take it as an exercise to how to derive this as a special case of that when the angles are very, very small. When angles are very small, sin I is approximately I and cos I is approximately 1. Hopefully you know this. Anyways, now that I have presented the whole thing, you can start with the sheet. The first question, try the first question. This is very, very interesting. I will start at 11:15. फिगर बनाना है क्या पढ़ाएगा So this is sheet number 4. Question number 7 diagram. And the diagram is something like this. You have a concave mirror here, and in between them you place a glass slab. You have an object here, the distance is given to be x, this is given to be 9 centimeter, and this is given to be 10 centimeter. Very interesting question, try this. Achha, I should make that correction. When I was talking about see in the question previously I was talking about you have a virtual object here and the rays are hitting here, so I should consider incidental error. I should not. I should consider where the object is placed. It's in rarer, so I should consider rarer to go like this. I think only correct. If that is the case, then everything else will follow. Check करना एक बार, ठीक है? Where your object is placed, I think that matters. Should I start with the question? Option B. Option B. Option B is incorrect. Option A is what? How many centimeter? 20. Incorrect. 24 is correct. Should I start? If you don't get this one, it's okay. This is a hard question actually. At least for the first time. Let's start with the question. Firstly, I think in the A part of the question they are asking how many refractions and how many reflections. So how many refractions can somebody tell me?
4.
4, right? There will be a refraction when you go through this surface, then another one, then the ray comes back and another one. So in total 4 refraction, there will be 1 reflection due to this concave mirror. Na? So 4 refractions and 1 reflection. Now they are asking where should the object be placed? This X is something that we can control. Where should that be placed so that the final image and the object coincide? Coincide. If this glass slab were not to be there, then it's a very simple question. You should place where? Center of curvature. If you place your object at center of curvature, your image will be formed at center of curvature. Very simple. But now you should understand, due to all these shifts, there will be shifts, right? Let me ask you this. There will be a shift when the ray is going from here to there, due to a real object. Real object you is a shift hoega towards the mirror or away from the slab? Towards the slab, na? Towards the slab there will be a shift. There will be a virtual object, virtual image will act like a virtual object for this thing. That virtual object will suffer some kind of reflection. Yeah? Comes back, again there is a shift. And the shift is now towards where?
Away from the slab.
Away from the slab. Why? Because that's virtual. Do you understand it? So we will go step by step. There is a shift first, there is a reflection, then there is another shift. So let's do this. So what is the object distance, the real object distance? That's 19 plus x na? From the pole. That's 19 plus x centimeter. The first shift occurs. In the first shift, it's shifted towards the glass slab. And how much amount of shift? Can somebody tell me? Shift का formula क्या था?
T into 1 minus 1 by mu.
T into 1 minus 1 by mu. Now what is T?
9.
And what is mu?
1.5.
So that's 3 by 2. So this will be 2 by 3. Yes? Will you get 3 out of all of this? 3 centimeter. 3 centimeter towards the slab, right? So I think your image I1 will be formed here. So this will be 3 centimeter here. So what should be this distance then? We should subtract 3 from this, right? If I subtract 3, I will get V1 as 16 plus 6 centimeter. Do you get it? This is after first shift. This will act like a what?
Virtual object.
For what?
The mirror.
The mirror. It will act like a virtual object for the mirror. Okay? Let's assume that if I place this at center of curvature, then where will my image be formed? At center of curvature. It will be formed somewhere here, somewhere in between. And then that image will suffer another shift. And that shift, I just have to, wherever I find it, let's say, for the sake of the discussion, I find somewhere here, I2. That is the image formed after the reflection. Huh? Then after shift, where will the third image be formed? Just 3 centimeters this side. 3 centimeters this side, yes or no? 3 centimeters this, I3. And what I want, समझ नहीं आया. I1 तक समझा? I1 is the image formed after the shift. That shift, अब वो ray गया, that will hit the mirror. That will create an image. That is I2. ठीक है? That I2 will suffer another shift. When it comes back तो वो शिफ्ट होएगा ना, शिफ्ट होएगा तो कितना से शिफ्ट होएगा? 3 से ही शिफ्ट होएगा. किस तरफ इस टाइम? Away from the mirror. तो इधर शिफ्ट होएगा. What I want in the question, see in the question they are asking that your this thing and this thing should coincide. It's not the I1 that should coincide. It's not the I2 that should coincide. It's the I3 that should coincide with the O. That is what they are asking. Okay? So I already know I1 will not coincide. I2 should be formed somewhere so that plus 3 if I add then this will form here. है ना? तो बताओ, if I place my I2 at center of curvature, my image will be formed at center of curvature? Yes. And if I add 3, will I get O? Let's try to get that. So if, let's say, if I1 is formed at, this I1 will act like a virtual object for the mirror, no? This if I1, so I1 is virtual object for mirror. If it is found at center of curvature, then can you tell me what is center of curvature distance? By the way, I think focal length is given.
40.
तो 40 होना चाहिए ना? तो this should be equated to 40. So 16 plus x is equal to 40. Then what is x? 24. I found my x. But now let's try to check whether my final image will actually coincide or not. ये 24 की वजह से इधर कहीं इमेज बनेगा and that will be shifted by 3 centimeters again. 27 पे आएगा तो I3 will be formed at 27 centimeter. Can you check कि this is correct? I'm assuming that my virtual ये जो I1 है ना, it's formed at center of curvature. I'm assuming that. I don't know that whether it's correct or not, but I am assuming that will act like a virtual object. That virtual object is placed at center of curvature. So my virtual image is also formed at center of curvature, and that will be shifted now. है ना? So where will my virtual image be formed at? बताओ, किधर बनेगा? It will be 40 plus 3 ना? तो it should be at 43 centimeter. अब मैं चेक करता हूँ मेरा ऑब्जेक्ट कहाँ पे प्लेस है. जरा चेक करो जरा. ऑब्जेक्ट 19 plus 24. 19 plus 24 कितना होता है? 43 होता है. तो ऑब्जेक्ट और फाइनल इमेज कोइंसाइड कर रहे हैं क्या? So if I place my if I find my virtual object at 24 centimeter, then my final image and that thing will coincide. Do you understand? This was very interesting stuff. So write this, and I'm not going further than this today. That is the last part. We'll actually go through the sheet in the next lecture and talk about this refraction due to a spherical surface now. We have talked about refraction due to a plane surface, next time spherical surface. And then we will start with the heart of this chapter, the lens theory. Okay? We'll introduce lenses. You can switch off the video. Bolo.